Hey everybody, this is Nick from First Coast Math Clinic. In this video, I'm going to show you how to solve systems of equations using the elimination method. This is a continuation of the introductory video on solving systems using elimination. If you want to check out that video, you can check out the link in the pinned comment as well as at the end of this video. Let's get into it. So our first system is 3x plus 4y equals -2 and 3x plus 3y equals -3. So we know our goal is to get a solution of xy coordinates, and using the elimination method we want to basically eliminate a variable. And to do that, I included the steps off to the right so we can double check what we're doing with these steps. So the first thing we want to do is get an opposite coefficient for one set of variables. So in the previous introductory video, this first step was done for us. In this video, I'm going to show you how to do that first step with two examples. So you get opposite coefficients for one set of variables. So let's look at our variables here and look at the coefficients for each variable. So we've got 3x, coefficient of 3, coefficient of +4, +3, and +3, right? So we want to figure out which is the easiest coefficient to make opposite. So we're thinking about basically least common multiples. Well, we notice that here we already have a 3 and a 3, right? So those are already the same value. We just need to make them opposite signs. So how do we make them opposite signs? Well, I can multiply, and we can multiply by -1. So if I multiply the entire left side by -1, it's going to change that sign from +3 to -3, and I've got opposite coefficients, right? This is +3, that's going to be -3. But think about our equation, right? We have to keep our equation balanced. Whatever we do to the left side of our equation, we have to do to the right side. So I'm going to multiply that right side by -1 as well. So we can distribute in the -1. Basically going to change our signs, and I'm going to rewrite the system here. So this is going to become -3x minus 4y equals +2, because -2 times -1 is +2, and then that bottom equation isn't changing. So again, we wanted to get opposite coefficients. We realized that we had 3 and 3. So to get opposite coefficients, all we had to do was change the sign of one of them. I decided to change the sign of that top 3. So to do that, I multiplied it by -1, and I need to multiply everything in the top equation by -1. So all the signs change. Second step, let's add the equation vertically to eliminate the variable from step 1. So we want to eliminate our x's here and here. So we're going to add vertically plus, and plus. So -3x plus +3x, well, those cancel out. That gives us 0. So those eliminate. -4y plus +3y gives us -1y. And 2 plus -3 gives us -1. Now we can move on to step 3, solve the resulting equation for the remaining variables. So we've got an equation that we can solve now. -1y equals -1. Let's divide by -1, -1. -1 divides out, and we get y equals 1. So in our solution, y equals 1. Step 4, we want to substitute the value into an original equation and solve for the second variable. So I'm going to let's use this bottom equation. It doesn't really matter which one we use. We just want to use the original equation. So I'm going to use that bottom equation. So we've got 3x plus 3y equals -3. Let's take that 1, put it back in for y. 3x plus 3 times 1 equals -3. 3x plus 3 equals -3. Subtract 3, subtract 3. We're going to get 3x equals -6. I'm going to continue this up here. 3x equals -6. Let's divide by 3. Divide by 3. 3's divide out, and we get x equals -2. So our solution, write that a little neater, is going to be -2 and 1. Our last step, let's check. So in our top equation, taking the original top equation, 3x plus 4y equals -2. Our x value is -2. Our y value is 1. So let's do that substitution. 3 times -2 plus 4 times 1 equals -2, and I get -6, plus 4 equals -2, and I get -2 equals -2. So our solution checks in the top equation. In our bottom equation, let's see if I can squeeze this in here. So again, our y value is 1. X value is -2. Let's substitute our values in. 3 times -2 plus 3 times 1 equals -3, and we get -6 plus 3 equals -3. And then continuing up here, we get -6 plus 3 is -3, and we get -3 equals -3. So our solution checks in the second equation. Okay? All right, so in this equation, or this system, we went through that first step in particular, where we got opposite coefficients for one set of variables, and we did that by multiplying that top equation by -1. I could have also multiplied the bottom equation by -1 to get opposite coefficients. In the next equation, or next system of equations, I'm going to show you how to get the least common multiple if these values, 3 and 3 here, are not the same. All right, let's get into example number 2. All right, number 2 is -7x minus 8y equals 9, and -4x plus 9y equals -22. So we want to start with our first step, and we want to eliminate or get opposite coefficients for one set of variables so we can eliminate one set of variables and solve for the remaining variable. So I'm going to do this 2 different ways. So first way, I'm going to start by eliminating the x variables, right? I'm going to show you how to eliminate the x values, and then I'm going to show you how to eliminate the y values. So we're going to solve this 2 different ways. So what we basically want to do is we've got -7, -4. We want to make those opposite values. So what we're basically doing is finding the least common multiple. I have another video on finding the least common multiple. If you want to review that video, there's a link for that coming up right now, as well as at the end of this video. So for our least common multiple, we can create a table of values. Just multiply and figure out what our multiples are, right? So for 7, we've got 7, 14, 21, 28, 35, 42, 49. For 4, we've got 4, 8, 12, 16, 20, 24, and 28. Well, what's the smallest value they have in common? The smallest value is going to be 28 and 28. Okay, and what do we multiply 7 by to get 28? We multiply 7 by 4. What do we multiply? Let's do this in a different color. What do we multiply 4 by to get 28? We multiply 4 by 7. So to get those least common multiples, I need to multiply everything in this bottom equation by 7. And whatever I do to the left side, I have to do to the right side. And this top equation, I have to multiply everything by 4. And whatever I do to the left side, I have to do to the right side. Now, something else you may notice, well, if I just multiply by 4 and 7, they're still going to be negative and negative. They're not going to be opposite. They're going to be -28 and -28. So what I have to do is make one of these negative to change the sign. So I'm going to let's make this 4 a negative. Let's make that negative a little nicer. Let's make that 4 negative. Okay, could have very easily just made the 7 negative. I decided to make the 4 negative. We just want these to be opposite signs. So now I'm going to distribute the negative 4. Actually, this 4 has to be negative as well because it has to be the same value. So now let's distribute the negative 4. Negative 4 times negative 7, I'm going to rewrite the system down here, is going to be positive 28x plus negative 4 times negative 8y is positive 32y equals negative 36. In our bottom equation, 7 times negative 4x is going to give us negative 28x. 7 times 9y is going to give us positive 63y equals, and then we get negative 154 on the right side. Okay, so now we've got the opposite coefficients for one set of variables here, positive 28 and negative 28. So what do we do next? Well, we want to add vertically. So let's add, and add. Negative 28 plus positive 28, well, that cancels out, so that gets rid of our x value. 32y plus 63y gives us 95y equals negative 36 plus negative 154 gives us negative 190. Now let's divide, solve for y. Divide by 95 and 95, and we get y equals negative 2. So we have our solution for y. So I want to write our solution up here. We need to figure out our solution for x, our value for x. So I'm going to take our original equation. I'm going to take, I don't know, let's take this top equation. It doesn't matter which one we use. Sometimes one's a little bit easier than the other. In this case, I don't think it really matters. Let's take that top equation. I want to put the y value back into that top equation. So we've got negative 7x minus 8y equals 9. So we know our y is negative 2, so that y value is going to go right in here. Negative 7x minus 8 times negative 2 equals 9. Negative 7x plus 16 equals 9. We're going to subtract. Actually, let me get rid of that. Subtract 16. Subtract 16. So if I continue this up here, we're going to get negative 7x equals 9 minus 16 is negative 7. Divide by negative 7. Let's remember to keep our signs with our values. Divide by negative 7. And we get x is a negative divided by a negative is going to give us a positive. And we get x equals positive 1. So our solution here should be 1, negative 2. All right, I'm going to hold off on the check until the next example. I'm going to solve this one more time, but the next time I'm going to eliminate the y value. So I'm going to show you how to do this one more time, but we're going to find the least common multiple for our y values. 8 and 9, get rid of those y values. And we should get the same solution, 1, negative 2. All right, let's do this one more time. So here we are, we've got the same example. We know our solution should be 1, negative 2 from the work we previously did. The previous method of solving, we eliminated our x values. When I solve this time, I want to eliminate the y values. So again, we want to find the least common multiple for our y values. We notice this may be a little bit easier because these signs are already opposite. We have a negative here and a positive here. So we just need to find our least common multiple for 8 and 9. Some of you may already figure out what that is. If you do, good. If not, I'm just going to go through the steps to do this. So just creating our table. Let's write this out. We've got 8, 16, 24, 32, 40, 48, 56, 64, and not 80. Let me try it again. Just getting ahead of myself. 72. And then for 9, we've got 9, 18, 27, 36, 45, 54, 63, 72, and there's our 81. All right, so what's our least common multiple? What's the smallest value they have in common? Well, smallest value is that 72. All right, so 8 times what is 72? Well, 8 times 9. And for the 9, what do we do to get 72? Well, 8 times 9. So in this top equation, I need to multiply this top equation by 9 and 9. And this bottom equation, I need to multiply by 8 and 8. And since I already have a negative and a positive, I already have opposite signs, I don't need to change the sign. I don't need to make this like a negative 9 or negative 8 like I did in the previous method of solving when I eliminated the x's. So that's already done for me. I could just multiply by 9 and 8, and I'll get opposite coefficients for my y values. So let's distribute in the 9. So when I distribute the 9, we're going to get negative 63x minus 72y equals 81. And when we distribute the 8, we're going to get negative 32x plus 72y equals negative 176. So again, we notice that here, we did that. Our y values have opposite coefficients of negative 72 and positive 72. So that makes our next step pretty easy. So we could just add, and add vertically. So if we add vertically, negative 63x plus positive 32, plus negative 32x gives us negative 95x. The y's cancel out, and we get negative 95 on the right side. 81 plus negative 176 equals negative 95. So let's divide by negative 95 and divide by negative 95, and we get x equals positive 1, which checks with our solution here. Let's solve for our y value. I'm going to use the bottom equation here. So let's use this bottom equation. So x is 1. Let's put that 1 in for x. So I'm going to have negative 4 times 1 plus 9y equals negative 22. Negative 4 plus 9y equals negative 22. Let's add 4. Add 4. Finish this over here. Going to, let me clean this up. So we have a little bit more room over here. So I'll have 9y equals negative 22 plus 4 gives us negative 18. Divide by 9, and we get y equals negative 2, which checks with the y value in our solution. All right, so our solution for eliminating the x value or the y value, we got the same solution, 1, negative 2. Now let's do our check. X value is 1. Y value is -2. So I get -7 times 1 minus 8 times -2 equals 9. -7, that's a 2, plus 16 equals 9. -7 plus 16 is 9, so we get 9 equals 9, so that checks. And then if we use the second example, the bottom equation, -4x plus 9y equals -22. And our y value is -2. Our x value is positive 1. So we're going to have -4 times 1 plus 9 times -2 equals -22. -4 minus 18 equals -22. And we get -22 equals -22. So the solution checks in the second equation as well. All right, so in this video, I showed you how to solve systems of equations using the elimination method, including the first step, getting opposite coefficients for one set of variables. If you like this video, leave a like, comment, and subscribe, and check out the link for the videos that are coming up right now, the introductory video on solving systems using elimination, as well as finding a least common multiple. This is Nick from First Coast Math Clinic.